So we have here a similar, actually this is just a similar problem with the previous problem, no, that we have discussed, but this one, we have a, if the punch strikes the mass off center, the steel bar may vibrate in torsion. So ganiya, ang puncher strikes at the center of the mass sa object. Now this one, yung there is a first part, is that the punch strikes the mass off center. So, wala sa center. Therefore, na, the mass may, or the steel bar may vibrate in torsion. So, we have a given mass which is equal to 1,000 kilograms. And then we have the length of the bar equal to 0.25 meters rather. And with a square cross section that is 0.1 m on side. So our area is 0.1 m squared, or that is just equal to 0.01 square meter. And then the mass polar moment of inertia of the tip of mass is 10 kilograms per square meter. And the polar moment of inertia for a square bar is b to the fourth over 6. So dito no, nagamit na taog, we have the polar moment of inertia. So why is this? It is because naanatay torsion na involved. Let's say our mass polar moment of inertia is equal to 10 kilogram per square meter. Let me correct this one. Square meter. And then the polar moment of inertia for a square bar is equal to b to the fourth over 6. Compute the torsion and longitudinal frequencies. So, duha itong gipangita nga torsion. We have here, duha ka stiffness rather. We have the due to torsion and due to longitudinal or the axial. Or, ato na lang mo KL. K sub L. And then here S, which is larger. Natin tayo given, modulus of elasticity, 200 GPa or gigapascal. And then here we have G. This is the modulus of rigidity as discussed na ko on our introduction. And here we have rho. This is the density of the steel. So, sabi buhaton na to ani first. So, we have the torsional. Isolve na to si torsional. And then, isolve na to si longitudinal. So, ito sa first isolve ka sa si longitudinal or the axial stiffness. Okay, dali naman, that is just K is equal to EA over L. So, we have 200 times 10 to the 9 Newton per meter. So, anong 10 to the 9? Newton per square meter. 10 to the 9, that is giga. No, giga means 10 to the 9 times 10 to the 9. And then times the area nga 0.01 square meter. Cross-sectional area over 0.25 meters. So that is equal to, so ito maning nasolve na ganiya, the axial stiffness that is equal to 8 times 10 to the 9 Newton per meter. Next, ang natural frequency. Its natural frequency, let's say this is KL, no? Is equal to the square root of, we have the axial stiffness or longitudinal stiffness, KL over mass plus rho b squared over L 3. So, na additional parameters gihatag. So, this is just equal to, or K is 8 times 10 to the 9 Newton per meter over the mass, which is equal to 1,000 kilograms, plus the rho, 780 kilograms per cubic meter, times b squared, What is our B? The side of the square, that is 0.1 meter squared, times L, which is 0.25 meters, over 3. Taas kayo, no? So our actual stiffness for this one, that is equal to 2,008 8 times 10 to the 9 divided by square root of 8 times 10 to the 9 Newton per meter over 1,000 plus 780 times 0.1 squared times 0.25 over 3. We have 2,819.186 radians per seconds. This is our longitudinal natural frequency. So, nganong naman ni 7.8, nganong naman ni naapil nga rho b squared L over 3? Actually, this is to take into consideration na dayon si square bar because on the system, last time no, negligible mo ni siya. This time, di-appeal na ni siya, and then this one. So, we have our natural frequency equal to 2819 or 2,819.186 radians per seconds na longitudinal frequency. Next, let's try to solve the radial or the torsional rather frequency. So, first is we try to get the torsional stiffness. So, the torsional stiffness, no, that is just equal to, katong discuss na ko last time, that is equal to the, we have the modulus of rigidity, and then, but this time that is times the polar moment of inertia over the length. So, we have the modulus of rigidity, 80 times 10 to the 9 Newton per meter, square meter, times our moment of inertia, polar moment of inertia, for the square, that is B4 over 6, or simply 0.1 meters over 6 to the 4th, just 0.1 na lang ato ang kuan, ato ang B4. 0.1 meter to the 4th over 6 over the length of the bar, which is equal to 0.25 meters. So here we will have a result equal to 5.33 times 10 to the 6 Newton meter per radians. So mo siya our torsional stiffness. Then our torsional natural frequency, that is just equal to the square root of the torsional stiffness over the mass polar moment of inertia. So, si mass polar moment of inertia, dili siya gamiton and replace ni mass. So, with that is equal to 5.33 times 10 to the 6 Newton meters per radians over, that is 10 kilograms per square meter. Then we will come up that our torsional natural frequency is just equal to 730 radians per seconds. And if we recall, no, our longitudinal frequency, natural frequency is equal to 2,819 radians per seconds. So you will know which is larger. Of course, our longitudinal stiffness is larger than the torsional stiffness.